Hey there, science enthusiasts. Today we're taking a lively stroke to the fascinating world of ion channels, nerve signals, and some of the clever ways we can keep our brains and bodies humming smoothly. Picture the tiny but mighty voltage-gated sodium channels are like gatekeepers on our cell membranes. When they open, sodium ions rush in, creating an ionic conductance pathway that sparks neuronal excitability. It's like flipping a switch that turns neurons on, allowing signals to propagate through the nervous system, a process known as signal transduction. When these channels misbehave, sometimes mutations can cause their activity to go haywire. For example, in hemiplegic epilepsy or certain forms of autism spectrum disorder, pathogenic mechanisms involving sodium channels can lead to excessive neuronal firing or impaired communication. Scientists have developed sodium channel blockers like carbamazepine, lamotrigine, and phenytoin that act like peacekeepers, calming overactive neurons in epilepsy and some arrhythmias. These anti-epileptic drugs help restore balance by modulating sodium conductance, ensuring signaling doesn't get out of control. Antiarrhythmic drugs such as lidocaine, furosemide, and quinine use these mechanisms to stabilize heart rhythms. Sodium channels aren't the only players. Calcium channels are crucial for various processes as messengers that influence hormone secretion, muscle contraction, and even memory formation. Calcium channels blockers can help in conditions like hypertension, showing just how vital ion channels are for homeostasis. Neurotransmission relies heavily on ion channels, especially potassium, calcium, and sodium channels. They work together to generate receptor potentials, which are the electrical signals that enables us to hear pulsations, control peristalsis in our gut, and coordinate skeletal muscle contractions. Glial cells like astrocytes and microglia also participate in glial transmission, supporting neurons and maintaining brain health. On the genetic front, sometimes mutations cause gain of function in channels, lead to epilepsy, or contribute to syndromes like Dravet syndrome. In these cases, gene therapy shows promises of future treatment. The brain and endocrine system communicate through intricate pathways. The pituitary gland, often called the master gland, releases hormones that control things like growth, metabolism, and reproduction. Different cell types in the anterior pituitary, somatrophs, thyrotrophs, corticotrophs, gonadotrophes, melanotrophs, and lectotrophs secrete hormones that regulate our body's balance. And there's even an interesting phenomenon called voltage-dependent hysteresis, where ion channels don't just switch on or off, but have a kind of memory influencing how they respond to changing electrical signals. From tiny ion channels to complex hormonal pathways, our bodies are like an intricate orchestra with countless players working in harmony. So next time you hear a heartbeat, enjoy a breath, remember a happy moment, remember the incredible cellular machinery making it all possible. Science is truly astonishing.